Welcome to REMA's session MLR211. Today we are going to discuss various things about computer vision. Most of you might have heard about it, and some of you might be working on some similar project where computer vision or machine learning model is involved. Today I'm going to take you through the journey that how you can develop, build, test, and deploy your model at the edge. So this is our agenda. Through the whole journey, I'm taking through ASL model, which is called American Sign Language. I'm going to discuss that why I chose this project, to give you an overview about machine learning models, what is our motivations, and then Sarita will be discussing, she was my colleague, she will be discussing that, okay, what will be the deep learning. She'll give you a deep dive into the deep learning model and AWS machine learning stack. Then Arno, my another colleague, he will discuss and give you the strategy about machine learning model deployment at the edge. So why diversity and inclusion? Most of you might have heard about diversity and inclusion at your organization and through your friends. And in the society, we do care about it. But through the journey, I'll tell you the personal story. Once, we all three were sitting in a New York coffee house, and we were discussing about various things. Then we noticed that in the next table, a couple were discussing and chatting. We are unable to understand because their conversation was on sign language. So we started interpreting that what exactly they're discussing. One of us said that maybe they're complaining to each other. The other of our friends, they said that no, it could be they are expressing their feelings. Then one of them said that it's good that no one can eavesdrop, but the world needs to hear them. And there we thought about that, okay, yes, the world needs to hear them. Why don't we develop an application, or someone should develop an application which should be camera-based, because everyone has now camera in their smartphone, where you can show to them, and that can convert the sign language into the text and speech. Learning that, we embarked on a mission that let's develop a prototype based on computer vision model. That's what we learned American Sign Language, because any machine learning model, first thing is doing the research, right? And after that, you need to collect the data. Then you need to clean the data and label the data. And that was our first step. We all three learned the model, learned the American Sign Language to make sure that, okay, we are building as a computer vision model. That was very tedious task because we are new to American Sign Language, and we learned that it's not easy to learn at this particular age. So we thought that, okay, why not gamify the whole solution when we are developing this model? And that's what we learned, that it's difficult because American Sign Language consists of 26 letters, 9 digits, and a lot of other gestures. So we simplified our prototype. We made it only 26 letters and choose it, and then collected various images so that we can develop the model. So our main motivation was, obviously, we do care about the society, about diversity and inclusion. We wanted to develop a computer-based model so that everyone can learn that, okay, how a computer-based computer vision model can be deployed at the edge, and obviously inspire the learning. The next step was, after collecting the data, that, okay, which approach we need to choose. There are two approaches. People are in the scientific journal, people are doing research in American Sign Language. One is sensor-based, where you need to wear a gloves, or you need to wear different sensors, and it gives you input to the machine, and that machine converts the interpretation into text and speech. Second one is image-based, which is again computer vision-based, where you have a camera, you deploy a model at the edge, and you perform the sign language in front of camera, and camera will be able to interpret. Obviously, the second one needs better understanding of deep learning. So I am going to invite Sarita, one of my colleagues, and she is going to give a deep dive into machine learning model, and also going to tell us about AWS ML stack. Sarita, over to you.
Thank you so much, Ashwini, for setting the context here. Hello, everybody. It's been a pleasure to come here and join you all for presenting one of our art of the practical solution. We call it as an ASL interpreter. Now, before I jump in, let me give a quick introduction about myself. I am Sarita Joshi. I'm a Senior Data Science Manager with AWS Professional Services. Together with my team, I help our customers and partners on their mission to achieve customer outcomes by machine learning and artificial intelligence solutions at scale. That's me. With that being said, now let's try to align on the mental model of what is artificial intelligence and what is deep learning. A very simple definition of artificial intelligence is the ability of a computer to process information and make informed decision. Now, deep learning is a subset of ML composed of deeply multi-layered neural networks that can perform tasks like speech recognition, image classification. That's the agenda for today. So that's where we're going to double click and understand what is the science that it takes to create a system that is smart enough to identify a picture. Now let's take an example on the screen here. On the extreme left, what you see is a pet, a dog, right? We are trying to feed that system through a bunch of layers. We call it as convolutional neural network. The output of that, as you traverse through the architecture on the right-hand side, you will see that what we are trying to do, hey, is that specific picture a dog, a beach, or an outdoor? And with that, you have a probabilistic distribution saying that the specific input has a probability of X to be a part of that specific class. That's in a nutshell what we are trying to do, and that's the back end of the system that we have built. So let's double click, let's go even further beyond what happens, right? In a system like this, we call it as a convolutional neural network. It is composed of two different aspects. We start with the first aspect, which you can see at the screen at the extreme bottom, which is the feature extraction, gathering the information. It happens in 3 layers. We start with a convolution. Think about this as on the same picture of the dog, you have a pixel, right, a 4x4 pixel. That is nothing but a patch. That is the first layer called as convolution. Once we have that, we take it to the next layer, which is introducing non-linearity to the data set. Now, why do we need that? In real life, all the data sets that we deal with are non-linear in nature. Last but not the least, because it's massive volume of data, we focus on the third aspect, which is called as pooling. What does that mean? We try to reduce the dimensionality, but ensure that the spatial information is considered. Now, that's the feature extraction. Once we have that, now we are trying to do a task. The task here is classify an image. Now what we do, we run those features over multiple layers. We call it as fully connected, and the output of that is a probability of a given image belonging to a specific class. That's the science, or I would say the state-of-the-art solution that is considered in order to have this ASL interpreter deployed end-to-end. Moving on, so what we learned? We understood the domain. We take a step back and now see, to make this happen, what kind of data do we need? A model is only as good as the data. So our stepping stone to make this vision a reality, we started with this public data set, which is composed of, as you can see on the screen, all the alphabets going from A to Z, and we also have numbers running in from 1 to 9. For the sake of this solution, the first phase, we will only consider finger spelling, meaning we consider static images. Those images are the total training size that we are dealing at this point in time is 72K over the sample size, the number of classes that we are dealing with are 29. So think about a class running from 0 to 28. It represents alphabet A to Z, and then we have some other, say, space, or say do nothing, or say delete, and stuff like that. That's a representation of our data set. All right, so now think about wearing a data science hat. You have a business problem. You know the ML problem to frame for. You are given a data set. What next? You need an experimentation ecosystem. You need a system to train these hungry neural networks, which are hungry for data, which are hungry for compute. How do we make this happen? That's the beauty of SageMaker Studio. Amazon SageMaker Studio is a fully integrated development environment for machine learning workflows. We leverage this as a team of 3. What we did, right? It's a heavy collaboration for, say, X months. So the beauty of this unified platform is, in one click, it allows you to collaborate under a given project. Here, our project is ASL. Once that is done, we move into the next step, which is rapid experimentation, right? Given 3 people or a team of data scientists, a team of researchers, a team of engineers, you have to build, train, test, and repeat the whole cycle over and over again. Another feature that SageMaker Studio provides is the mechanism to track these experiments from point A to point B so that you can pick the right choice, the right training model for a given timestamp. Once that is done, now you have to iterate over a variety of tunable hyperparameter optimization jobs to identify what is that best model that I can call it as a baseline model for a given problem that I'm trying to solve. That's where the automatic model generation comes into play. Last but not the least, as I said, right, it's a journey all the way from data collection to the point that you have a baseline ready. Now, think about software, right? Things might go wrong. We need to have a mechanism of tracing the error, identifying why those errors are occurring, and ensuring that we are able to trace the accuracy, the objective metrics. That is where SageMaker Studio, again, provides an integrated platform wherein we are able to monitor, we are able to trace, and we are able to maintain high-quality model. Again, think about what is the KPI? What are we trying to achieve here? We are trying to improvise the productivity of the data science team. We are trying to improvise the time it takes to push a model to production, thereby boosting the productivity of the entire team due to the use of Amazon SageMaker Studio. All right, as Ashwini mentioned, a very high-level overview of the AWS ML stack. We are focusing throughout this agenda today, we are focusing on the middle tier, which is the SageMaker Studio IDE that we already discussed. We start from data collection, we do feature extraction, we do some manipulations with the data. Once we have the model built, we push it to the edge, and then Arnab, towards the later half, will walk us through what the deployment strategy looks like for edge computing. The last layer, as you see in here, we are using MXNet as a framework that is provided to you for deep learning. The other pieces that are mentioned as a part of the third tier here is the GPU-based instances. So we will be using P2, P3 instances as a part of this ecosystem. All right, with that being said, now we have a broad set of tools that are available at our fingertip to identify the right set of tool sets, the right set of data, and start the experimentation, or I would say the research. So in a nutshell, what we are using here is we are using the inbuilt algorithm provided by SageMaker called as image classification. It's a supervised learning approach that allows multi-class classification. In this case, we have 29 classes. We are using convolution neural network. With respect to the data type, right, think about some data wrangling, data massaging. So what happens is this algorithm provides you 2 types of data sets that you can use. The first one being the record.io format. The second one is the list format. As you can see it on the right-hand side, that is a sample definition of what a training list file might look like. You have a bunch of images, we call it as JPEG files. You have the class representation that can go from 0 to 28 because we have the total size being 29. And then the first column is nothing but a random index. So that's a list format that you will feed in as a part of your training job. Like I mentioned in the previous slide deck, we are using the MXNet deep learning framework. Now, with respect to the compute on optimizing these models who are hungry for computational resources, we are using the P2 instances, which are available as a drop-down that can be scaled down or that can be changed dynamically because SageMaker Studio provides elastic compute. Last but not the least, when we say we are trying to build a baseline, that means we have to measure on some of the objective metrics. The metrics that are important here are the training accuracy, the validation accuracy. So that's in a nutshell the science to make this thing happen. All right, so now let's take a step back again. We have a baseline model ready. Now we say, this is my platform engineering team who is now going to take this model and push it to an edge. An edge can be an AWS Deep Lens device per se. Now, before I do that, what is that benchmark or what is that test mechanism? So what we do as a data scientist or a data science team, we will try to test that model. As you can see it on the screen, given an unseen image, which is nothing but a finger spell of A, the probability of predicting that to be A right now is 99%. The threshold that we think that this model is good enough for us is 95. So we are way beyond exceeding that threshold. That is where, as a data science team, we are confident enough to start with the business goal. Once we have the ML framework, we started with the data layer, we do the model development, it's in the stage, we give a thumbs up saying that we are ready for deployment. So that's the whole journey of how we started training a baseline model for this given exercise. With that being said, now I'll request Arnab to walk us through the deployment strategy of what it takes to take this artifact all the way from the S3 buckets to push it to the edge. Arnab, over to you.
Thank you, Sarita, for the scientific deep dive. Hello, everybody. My name is Arnab Ghosh. I'm a solutions architect at AWS. In this section, we are going to talk about the solution architecture, how we did it, right from how we trained the model, we build it, and then finally deployed at the edge. And then I'm going to also walk you through this small application that we built on top of this to sort of gamify the American Sign Language learning experience. To start with, let's first talk about the model development. In model development piece, as Sharita pointed out, that we are using SageMaker Studio, and that is our ML environment. But what does it give us? It gives us the ability to code, to run it in Jupyter notebooks really easily, develop the model, and then train the model. And then the most important thing, track the whole ML, the workflow, that how is it doing, the accuracy, the prediction, which is really, really important as a team. In this architecture diagram, I want to highlight Amazon Simple Storage Service. This is, throughout my architecture review, you will see that we are going to focus this as our storage layer. This is an object storage, provides industry-leading capabilities like security, scalability, and we are using S3 to store the training data set, the intermediate results, and also the final model artifacts. Now, next thing is, before you use that data set and start training a model, generally data scientists do things like explore the data. Maybe you go ahead and do some analysis and then pre-process it, make it ready to start the training process. In this exploratory data analysis phase, we sort of do initial experiments, and that might include things like finding out if there is a pattern, find out if there are anomalies. Maybe we do some hypothesis that with this data set, can we achieve something or not? And this is really important. And I'll give an example. For image classification, that can be raw image compare, maybe image as matrices, find that out, find the variability. So these are important things to kind of do to understand how your data is. Next is augmentation. And we have seen that Sarita mentioned that we are using transfer learning. So we have seen that in transfer learning, data augmentation really helps, because what it really does is it kind of diversifies the data. So if you're working with a limited data set, it can be really important tool. Now, what did we do in terms of augmentation? We sort of used couple of different techniques. We used random rotations. We'd use things like changing the hue, saturation, so that to generate more variability in the data set. Moving on, now we are currently done with the training piece, right? We did the analysis, we went ahead and did the preparation. Now we are ready for the training. But before you do the training, it's important that you choose an algorithm. For you to quickly start, you can use one of the built-in models or algorithms that SageMaker already provides, and we exactly did that. But question is, if you are an advanced user, if your business case doesn't align with one stuff that is available in SageMaker, you can certainly build one of their own by using one of the supported frameworks by SageMaker, or even you can bring in a Docker image. We use transfer learning and use the image classification model that is provided by SageMaker. Transfer learning has been really popular when you are doing deep learning tasks like computer vision, like speech recognition. This is because the training a full neural network model needs immense amount of compute and immense amount of time, and to kind of reduce that, this has been a really good process. Next up, so now in SageMaker, to complete the training, you need to submit a training job, and that is basically simply few data that you need to provide. The location where your data is, the location of where you want the artifacts to be, the hyperparameters. Sarita mentioned that we have to tune those, and we did it a lot of times. We are going to talk you through those. And then obviously the compute. And we mentioned that we are using the p-type compute for the GPUs. So once you submit this job, SageMaker is going to provision these resources, use your code and the training data set to train the model, and once it's ready, it will be available in S3. Very important piece is the validation. Once your artifact is ready, you need to validate to ensure that it matches the business requirements that you have. We iterated multiple times. We created multiple training jobs, changing the hyperparameter to ensure that we reach that threshold level of accuracy that we thought was important. Okay, so now my model is ready. Next up, let's look at deployment. So once your model is ready and has achieved the accuracy that you think is your threshold, that's when you decide to deploy the model and then run the inference at the edge. For our scenario, we chose AWS Deep Lens to deploy our model and run inference at the edge. Now, one thing I do want to mention that we built this solution to be AWS native. That's why AWS Deep Lens is the obvious choice. But if you have like a Raspberry Pi based camera, sure, go ahead and use that. And maybe the deployment steps will change a little bit. Other than that, everything will be the same. So let me walk you through what is AWS Deep Lens. AWS Deep Lens is a deep learning enabled camera. It is integrated with several machine learning services and also has the ability to do local inferences on the deployed model. So the process, like if you want to deploy a project within Deep Lens, what are the basic steps? The first step is you need to have a model. We have it. It's already ready in SageMaker. It's a one click to import it. Next is we need a Lambda function. AWS Lambda is a compute service which is completely serverless. So you build this project function that has the ability to take frame by frame of the camera feed and then run it against the deployed model to generate the inference. Next is use the AWS Deep Lens service by itself, in which you create a project which consists of this Lambda function that you just created, the training model that we have in SageMaker, and then you create an artifact that will be deployed in this Deep Lens. Now, the final step is use AWS IoT Greengrass to deploy this artifact and also deploy a Lambda runtime. Remember, this is a compute. Even though it is serverless, it still needs a runtime. So you deploy it on your camera, so your package is fully ready. Now, what is AWS IoT Greengrass? This is a runtime edge service. It's a runtime that allows you to deploy and manage applications on your connected devices. You can use it to build applications, build software, to sort of have the ability that your devices can act on the data it generates. This is exactly what Deep Lens is doing. It is basically the model you are deploying, it is taking the frame and actually running the frame with that model. Okay, now the easy part of all this is Deep Lens is already set up with Greengrass. So it's a one-click deployment for you and all the configuration that is required. Next step, so now we have the model, we saw how the model is deployed in the Deep Lens, but we need one more thing. We need to actually store this inference result into a persistent data store. And why? Now this part may be little off our whole template, because in template we spoke about that we are giving you a template for deploying an image classification deep learning model. But I am going to also talk about we built an application on top of this to gamify the experience. So that data needs to be used by that application. So we chose DynamoDB as our data store. The reason being it's a NoSQL database and it actually is completely serverless. Next, how will the data end up in DynamoDB? This is where that inference function that I spoke about comes in once again. That inference function actually publishes the data into an AWS IoT topic, and then an IoT rule kind of transforms it and then writes it back into DynamoDB. Too many services, I know. So this IoT topic and the rule is part of AWS IoT core. This is a service which is basically a managed platform that allows your connected devices to talk to each other and cloud applications. Okay, so with that, now we have the model, it's deployed, and the results are going and sitting in DynamoDB. Next, we are going to talk about this small web application that we developed to gamify the American Sign Language learning experience. It's a simple JavaScript application. The UI is vanilla JavaScript jQuery. I know you might say, why jQuery? This is totally achievable by any of those modern frameworks. So go with React, go with Angular, whatever is your thing. Next is the backend. The backend is RESTful web services, and we have used Amazon API Gateway and Lambda-based request handlers. Again, see the theme here. We are trying to keep everything serverless. And this is really important in terms of architecture. Why is that? When we are running experiments, when we are doing POCs, cost is always a concern. And we have seen that when you design a architecture which is serverless, you tend to save cost. Again, this is something in our experience. Okay, now let's deep dive a little bit in some of these services to understand how it fits into those things. First of all, I told about Amazon API Gateway. What is exactly? Amazon API Gateway is a service that allows you to create, deploy, monitor HTTP RESTful WebSocket APIs at scale. Now, it is a fully managed service that reduces the undifferentiated heavy lifting of maintaining resources. It is sort of a serverless way of launching your APIs. We spoke about Lambda already. Serverless compute virtually can run any application. In our case, it's acting as a request handler. Next, we are going to talk about the edge layer. Why edge layer? If you can see, we are serving the content or the static content like the JS file, the CSS. We are serving or distributing this content through a content delivery network, which is Amazon CloudFront. Amazon CloudFront is a service that allows businesses and developers to distribute the content in a very cost-effective, efficient, and secure way with low latency and high throughput. Why is this important? It is important for any web application. If you have a global geography, you have different users across, this will give them that low latency. Again, ours is a POC, we may not have, but in your scenario, it is totally possible. We are just following the best practices here. In this architecture diagram, you will also see there are a lot of other services. Why is that? Security and monitoring. These are the core components of any architecture. And we have used some of our foundational security services and monitoring services when we designed this as well. I'll just go through a few of them really quickly that as to what importance is of those services are doing in this architecture. First of all, AWS WAF. This is a web application firewall. This is a service that allows you to monitor your HTTP and HTTPS traffic as they come into CloudFront and your Amazon API Gateway. So it gives you that ability to visualize what requests are coming in, both your static content and as well as your RESTful backend. Really important. Shield, AWS Shield provides protection against distributed denial of service attacks, and this has become a rampant in nowadays, so this is really important that you keep in mind. Next, we are going to talk quickly about CloudWatch. This is really important. This is our core monitoring and logging service. This is monitoring AWS resources, the applications that you deploy on AWS continuously, and reports your performance metrics which you can take action upon. CloudTrail, it's all about auditability. If you are a company who needs auditability, you needs every event that happens in your AWS account and be trackable, AWS CloudTrail is the service that you should enable. X-Ray, this is from a developer's perspective. If you are a developer, you know you have worked in microservice world, distributed system, tracing really helps to find out what broke. So this is a really great service for tracing all the different legs of your application request. Okay. So now we have gone through the way we developed the model, we deployed the model, and also we spoke about how we have this application sitting on top of it and how we designed it. Now, we will jump into a quick demo where we are going to see how our system sort of works. So, this initial picture is all about the setup. This is the AWS Deep Lens camera, really easy. It has the model deployed on it and is connected to a computer. There is no other extra components in this setup of ours. Okay, this particular window has two things. On the left hand side, what you see is the direct camera feed from the AWS Deep Lens. The text in blue is the direct result of the machine learning model. So, you are seeing the class as well as you are seeing the accuracy. So, here you will see that it says nothing, that means it is not predicting anything. Now, let us quickly say okay, how it acts when we do an A and a B, and you can see it can detect A and B with a fairly high level of accuracy. Okay. Now, we will jump into this web application that we built, sort of gamified experience. The idea is the user is going to quickly put a username and sign in. Once the user signs in, a random 4-letter word will be presented. Now, what the user has to do? Finger spell that word in front of the Deep Lens camera, and this is what we are going to try here. If the user is successful, you get +5. If you are unsuccessful, you lose a point. And now, this is the word is rail, and you will see that I am not able to do R, and I am going to fail. And if I do that, that turns red. That means I lost a point. But I will continuing. We are doing A, that was successful. We do I, that was successful, and then L, that was successful as well. So, now you see a total point is 14. So, it is just our version of how you can gamify this whole learning experience. It is a really simple application, but again the core is the template of deploying that deep learning model at the edge, and this application is just sitting on top of it to kind of gamify the whole experience of ASL. Okay. As we conclude, important thing, this is a research heavy area. There is lots of systems that has been designed that can interpret signs from images, but researchers in this field have still lot of challenges. What some of these challenges are things like position of your hand, the color, the shape, the distance of the hand from the camera, all of these are major concerns. And Sarita mentioned that your model is as good as your data. So, these are the things you have to keep in mind. Next is, in this state of the art solution, we designed a CNN based architecture where we can interpret American Sign Language alphabets. We did it using transfer learning, use Amazon SageMaker's built-in image classification model. Again, your use case might be totally different, but still this particular complete solution provides a blueprint, an art of the practical template which you can use to deploy a deep learning image classification model at the edge. So, what are the key takeaways? Very important. Deep learning is well suited for a variety of artificial intelligence use cases. For example, speech recognition, computer vision. Convolutional neural networks is one of the most commonly used deep learning techniques to classify visual imagery, and it has been seen that it needs less pre-processing than any other image classification algorithms. Next up, Amazon SageMaker Studio. This is a web-based, fully integrated development environment for machine learning. It provides you the ability to build, train, deploy, monitor your machine learning models at scale. So, it provides you all the tools that you need to take your model from experimentation to production, while give the ability for higher productivity or sort of boost your productivity. Then AWS Deep Lens. AWS Deep Lens literally puts machine learning in the hands of the developers. With a fully programmable camera, sample code, tutorials, pre-trained models, it gives you a definite boost to increase your knowledge on deep learning. And the final takeaway, I want to circle back to what Ashwini said, which is we as a team feel deeply about the importance of diversity and inclusion. And we have chose American Sign Language for exactly this reason as the use case today. These are some resources that is going to help you to get started. A blog is coming out where we are going to talk about all the different things that we did to achieve what we achieved. So I hope it will be useful for you. Thank you for watching.